Okay, so today is lecture 6, which is the beginning of the second of 3 modules in this class. And the second module is called Web 2.0, Websites as Applications. So this is the era starting around 10 years ago in 2004-ish. And today we're going to do the first lecture of this series, which is dynamic DOM manipulation with JavaScript. So the learning objective today is to be able to dynamically modify an HTML web page with JavaScript after it finishes loading. And we're going to do so entirely in the web browser without any server-side scripting. So most of the lectures in the first phase, remember, involve scripting on the server. And now we're going to bring it all in the browser with JavaScript. So last time, I'm just going to start with a recap of last time, which is that cookies enable the server to remember who the user is, even after you load the page again, which allows for things like user login sessions. So today we have a bunch to cover. So we're just going to first start with the recap of cookies. So the projector is actually good now. Okay. Good, thank you very much. That's pretty fast, 10 minutes. All right, we'll give them a good rating. So recall last time we ended with lecture 5 PY. We had this kind of hacky thing where we logged in by just putting that person's name in the URL string, which is not great. So I rewrote lecture 5 and put it on GitHub. And what you'll be able to do is if you go to, I guess, lecture 6, which is today's, you should be able to review the enhanced lecture 5 PY. So if you click there, you're going to get to see the code on GitHub. So you can just look at it directly. I'm just going to open it in the text editor, but really it's the same thing. Actually, I'll just look at it in GitHub because I won't edit it. So here's the behavior we're gonna have. Let's go to lecture 5 PY. So if you load the page, it just says you are not logged in yet, and enter your name and then submit. So this is like a login form. You don't have a password or anything. So I'm just gonna put my name in, and what it'll do is when we submit it, it will log me in and display my name and my picture and stuff. And notice how the server sends me back a cookie. So it sends a cookie. Now in the browser, the cookie username Philip is in the browser. So now I'm going to just load this web page again. The same URL, no Philip or anything in the URL. If I load the same URL again, now I am logged in. Now I go here. When I paste and press enter, I am logged in. So that's how you would visit Facebook or any site where you have a login. You don't have your name in there, obviously. And no matter how many times you do this, it will keep you logged in. And as you mentioned last time, to log yourself out, you can delete your own cookie. Or what happens is that the server can actually delete your cookie. So one common way, this is sort of a hack, but one common way the server deletes your cookie is that it sends you a new cookie and it sets the expiration date to the past, which is very unintuitive. But if you actually send someone a cookie and set the expiration date to the past, when they get the cookie, the browser knows to delete it because it's already expired. So that's a common way that servers delete your cookie. Or you can do it in JavaScript also, but the details are important. But the idea is that the server can delete your cookie. So imagine the server deleted my cookie. Now I go to the exact same web page and it says I'm not logged in. And I can log in as John or Jane. I think Jane's in the database. And now Jane has this picture. I'm going to go to another page, same URL, and we're Jane, right? So that's the basic idea, and I just want to briefly go over the code so that you can study for it for your exam coming up. So I've written some of the stuff out into functions just to make it look a little nicer. So this is just a function in Python. This is how you define a function. So when you call this function in Python, it will print out a bunch of stuff, it'll print a bunch of HTML. This is the not logged in page. If you look at it, if you kind of look at it, it says you're not logged in. There's a form, enter your name. There's a my name thing, and then you hit submit. So that corresponds to, this page corresponds to, let me log myself out. Resources, cookies, localhost, delete. So remember, I was Jane here. That corresponds to this page, right? You're not logged in, enter your name, submit button. So that is this right here, right? So when I call this function, I will print out all this to the response, so then they display that page. There's also a print logged in page, unsurprisingly, which takes a username as a parameter to the function. So let's say a username is Philip or John or whatever. What it'll do is open the SQLite database, opens this database, starts printing HTML, does an SQL query here for the username, hopefully finds in the database, and then prints out in H2 format your name, your age, converted to string, and this image, 300 width image, and the image's source is set to the image thing from the database, and then you print. So that corresponds to, after I log in as, let's say, John, that corresponds to that page, right? So I call that function print with John, and then it prints all these things out. And you should just be able to, you should definitely study how the code executes. So when you're logged in, it'll call this function. So right now, nothing's running. I'm just defining two functions. But because I define both functions, I can call them now. And it's much cleaner than, remember how during lecture I copied and pasted that code in the end because it was just, we're doing it in a rush. But it's obviously nicer to have these in separate functions so you can call them. OK, so these two functions are defined. And then here's the main code, right? The unindented code is the main code that executes. What this says is there's a form. So first of all, so the other thing I forgot to say is the action field in this form is lecture5py. So it's a little weird because this file is called lecture5py, right? Like this file is lecture5py. So when I load it, I am loading. Do I have a cookie? Yeah, I have a cookie. I am loading lecture5py. But when I actually submit the form, I'm actually loading the exact same file. Okay, and the only difference is when I load the file, I have a parameter that I'm loading it with called my name. So when I submit the form, what happens is I run this code right here, if my name in form. So this is run when you hit the submit button, because when you hit the submit button, my name is actually in form, and we're actually going to run this code. So what this does is it creates a new cookie with the username set to this, and it prints out the cookie, so it sends it back to the browser, and then it prints the logged in page information to log you in. So that corresponds to the following move right here. So that corresponds to, so this code, if you look at this if statement, runs when you, I have to log myself back out again. It'd be good to have a log out button, but didn't have time to implement it. That corresponds to, not this, but it corresponds to when I hit submit, it will load lecture5py again, because the form says to load lecture5py, but it'll load it with the my name parameter in the form equal to Philip. So this code right here executes as soon as it hits submit. So that was the code that executed. It gave me a cookie, right? It gave me a cookie here, and then it printed out a logged in page. So if I look at this, I submitted the form, it gave me a cookie, and then it printed the logged in page. So now when I visit this site again, I'm not going to execute this my name in form, right? Because I only do that when I hit the submit button. So every other time I visit this page, now that I'm logged in, when I go like this, or I go to new tab and go like this again, when I visit the page, it will not execute the if, it'll go down to here. So it'll go down to the second branch in the else. So this is all other page visits. Now there's two options. One option is if I don't have a cookie, which means I'm not logged in. This is like, remember the very, very first time it says you're not logged in? Then it just says, okay, you don't have a cookie, so I'm just going to print the not logged in page. So not logged in page means enter your username. If you do have a cookie, which is this case right here, I have a cookie, and I'm just going to the page. I have a cookie. So if I have a cookie, then I go down here, and I use the cookie. And basically, if I check that the username is in the cookie, that means that we're logged in as that person, and I'm going to print logged in page with the username. There's one other weird case. This is a weird case that I had to handle because remember that when you visit a page, you send every single cookie belonging to that page. So there could be a case where you actually the server receives a cookie from you, but it doesn't have the username tag in it. It's a cookie for, I don't know, age or current time or something. So you have to check this whether the username's in it. Because the username's not in it, you have a cookie, but there's no username cookie. So I still say, hey, you're not logged in yet. So if you study this code, there's actually 4 possible things that can happen. There's, if you submitted the form, okay, good, then we're logged in. If you didn't submit a form and you don't have a cookie, if you didn't submit the form, you do have a cookie and it has a username in it, then you're good. If you had a cookie but it has no username, you're still not good. So you notice how this code starts to get more and more if statements, but it's all kind of captured within one file. Now you could break it up into extra files if you want. You could be like, here's a file to handle the form, here's a file to handle other stuff. But for simplicity, I just stuck it all in one file. You could think about what you want to do in the actual project. But this is the most compact kind of code for doing the simple login form where you have this login functionality. So definitely study this on your own time. It's the same concept as what we went over last time, but it's just a little cleaner in format. Any questions about the cookie stuff quick question before we move on? Yes?
So what if your username is not in the database?
Yeah, so if your username is not in the database, what I think this will do is, well, I think this is what it does. It can't find it here. So this for loop never executes. So it actually just prints out a blank web page.
Oh, okay.
Yeah, so again, it just depends on your code. It just happens at this just prints out the blank page. Yeah?
So what would happen if you, after logging from the login page, you hit the back arrow, try to go back to the former page?
Yeah.
Go back and forth, what would happen?
So you're saying let's do a clean login? So like that?
Yeah.
Okay, well, back arrow. Yeah, so let's go here. So we're at clean login. So we'll say here. Okay, so we're gonna hit the back button, all right? So yeah, so this is one of the problems with having using post requests, right? That you don't change the URL. So then, so the thing with the original web and how the back buttons work is that you imagine every time you go back, you're going back to the previous URL you visited. But as you mentioned, we're all still at the same URL. So the back button's actually broken here. So people have to do all sorts of workarounds for not breaking the back button. So it's a great point. And the idea is that because you're posting, all your state, well, 1, you're posting, and 2, you have a cookie. So your state is no longer all in your URL. So that's actually breaking what the web was originally designed for, which is one URL is one unique resource. But right now, as you see, Electrify PY, if I just asked you out of the blue, if I just say, here's Electrify PY, here's the code, and I'm going to visit this page, what does it do? You have no idea because you don't know whether it's a cookie, there's no cookie, you don't know if someone posted a form or don't post a form. So whereas, for example, if I asked you, lecture1.html, what does this print out? Everyone will be able to see that because there's only one possible thing to print out. There's just an HTML web page, there's no fanciness going on. Cool. Okay, so definitely study the cookie thing. And we are now going to go to the main event. So the main event basically behind this whole section with Web 2.0 websites and applications is that we want to go from pages like this, like the Amazon homepage or whatever, where it's just a bunch of information, a document. So now if you look at Amazon, you can kind of see, oh yeah, it was generated by some scripts that grabbed some images out of a database and plopped it into an HTML web page, and we can visit it. And then if you click on any of these, you go to buy an item. Amazon makes it really easy to buy stuff, so I don't want to click anything because you can actually buy stuff that way. Make it notoriously easy. So an application like Google Maps feels a little bit more interactive, right? So this is what we showed in the first lecture, that yes, you load a map here, but as you drag, is that dragging not work? As you drag, it dynamically loads more and more tiles of the map while keeping the web page the same, right? It's not like you're clicking on something and it's reloading a whole other page with another resource. So fundamentally, these sorts of apps, which are called Web 2.0 apps, feel a little bit different than say visiting say GitHub or the course web page. Right? Like this feels like a web page, and I click on this thing, and I load a whole other web page. And I click on this thing, I load a whole other web page. I click on this thing. This is the Web 1.0, a web page is a document. One web page is one document. This is, the entire Google Maps site is sort of like an application you're playing with. You can zoom in, you can zoom out, and it will just load data for this on the server for you. Because obviously it's not loading the whole world at once, right? Like, you could imagine loading the whole world at once, but it's not very efficient. So as you're moving, it's calling the server to load stuff, and it can, you can zoom in as far as you want. So, yes? Yeah, I don't know what's going on here. But by the end of these next few lectures, you'll kind of figure out how to make an app like this, just like how the first series of lectures you figure out how to make the first kind of version of Facebook. So we're going to work toward this sort of Google Maps-like thing. Okay, but before we do so, we need to recap our HTML and CSS. So this is super, super fast recap. So let's go back to lecture 1. I have just copied lecture 1 into lecture 5. It's just, where's all the stuff? So or lecture 6. So I just copied it. It's just lecture 6. So this is lecture 1, right? This is the thing we built up. It's an HTML file with some CSS in it and HTML. This is lecture 6, which is lecture 1. HTML, and then there's head. There's a CSS embedded inside. So these are CSS selectors and styles. There's a body, there's heading, there's an image source, and everything. So this is HTML and CSS. So lecture 1. That was pretty much the recap. So what I make here, yeah, there's HTML and CSS. It's there. Good. Now we want to go through this thing called the HTML document object model. Okay, so this is the central concept from this lecture, this thing called the DOM or document object model. And I guess, from kind of your readings, we can let's start brainstorming. If I tell you, what is the difference between like HTML and the DOM or document object model? Like, what are some of the differences between that? It seems really similar. Initial thoughts? Yeah. Good, good. So the CSS can be in the HTML also, right? But yeah, so what you said was HTML is the language that specifies, that's what you code in, right? Like you write, that's exactly right. You write HTML, which is, you type on your computer all these things in this format with braces, and you save it to a file. And then the DOM is this tree structure that's generated in the computer's memory. So I think that's the fundamental difference, is that the DOM is an object. It's a tree object. And HTML is just text. I mean, it's both the programming language or the markup language and the text file you're saving. So this lecture6.html lives on my computer here. It lives on my computer right here, or it will live on the server somewhere. It's a file. It lives there, and the web browser takes the HTML file, loads it, and then generates what's called a DOM tree out of it. And the DOM lives inside of the web browser's memory. So I guess the picture here would be, let's do yet another wonderful laptop drawing. The picture is you have a browser inside. In your computer inside, this is gonna look not great, but in your computer inside, there's a hard drive here. And then there's a lecture6.html. There's a file right here called lecture6.html. It's on your hard drive. You turn off your computer, it's still there. It's on your hard drive. When you open your web browser and load lecture6.html, it will load it in, and then it'll create this tree-like thing. There's nodes and leaves, and it's a tree-like thing. And that's called the DOM or the DOM tree. And that lives inside of your web browser's RAM, inside of the web browser's memory. So when you close your web browser, it's gone, right? When you close your web browser, the DOM is gone, but the HTML file is still there because it's just sitting on your hard drive. Perhaps a more accurate picture, so this is if you just load it from your computer. Like you can just open an HTML file, just like lecture 1, double click and load it from your computer. But on the internet, you're gonna go through a server. So it's a really similar picture that when you go through a server, then the file lives on our wonderful server right here. Wow, my screen is like cropped. That's weird. Okay, so there's a file on the server called lecture6.html. Then you make a request. You have the URL, blah, 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 HTML. Make a request. This server software fetches it, sends it back to you through the same protocol. And now you fetch all this data, all these ones and zeros, and then you build up a DOM tree here. So this is the DOM tree you build up in your browser. Does that make sense? So in your browser, once the HTML is loaded, it's in what's called a DOM or a DOM tree. And the DOM looks sort of like your HTML. If you actually look at your HTML, the structure of the code in HTML, it does look like a tree, right? It describes like with nesting and everything, and you can indent if you want to make it clear. So what does the DOM tree look like? I'm just going to go to lecture 6 here. I'm going to reload the page. You do that. You look at that by doing inspect element, and again, you can inspect any element. And now you go to elements, So elements is your DOM tree. So this pane in Chrome is the DOM tree right here. All right, so if we look inside, we see that it looks sort of like the HTML. It actually preserves the comments, which is nice, but you can collapse it. So a tree is just an outline or a hierarchy. So you open the HTML, inside you can open the body. Inside there's a my heading, subheading, whatever other stuff. Now the cool thing about modern browsers is when you highlight over this, it actually shows you on top what part of the HTML is being rendered. So this is super useful because you know now that this thing is this thing, and then when you highlight over, say, the image, it knows that this is the image right here. So this is the internal representation in memory of the file you just loaded, and then it's rendered in the browser like that. So that's basically going from HTML to DOM. So what the web browser does is the web browser, like this is the job of the web browser. The job of the web browser is to take an HTML file with some maybe CSS or other stuff in it or link to it and convert it into a DOM tree so that we can do stuff with it. So in lecture 1, that was all there was. Like all you could do is take an HTML file, load it in a web browser, and then we're done. So we had some questions of, once your page finishes loading, what do you do with it? All right, so now my page is completely loaded. Yes, question?
So JavaScript converts HTML to DOM.
No, there's no JavaScript yet. I didn't mention JavaScript, right? It was a mistake if I did. So there's no JavaScript. Erase your ears if you heard JavaScript anywhere. There's no JavaScript right now in the world. Pretend like JavaScript doesn't exist. So the web browser does that. So the web browser loads your HTML files, and it converts it into a DOM tree. And you can see it down here. So there's absolutely no JavaScript involved at this point. Other questions? So that was the extent of lecture 1. Lecture 1 was HTML and CSS, which is all within the same file. So the problem with lecture 1, obviously, is after you load the page, you're done. Like you can't do anything with the page. Like you're completely done. If you want a new page, you better click on a link or reload it or go to another URL. You better go to another page. Like as far as you're concerned, this is all you see, which is good enough if it's a document, but nothing can move and nothing can be interactive. So in order for things to interact on the page itself, you need something else, right? Like just if you actually look at HTML and CSS, that's not enough to have interactivity and to have the stuff that you would expect of applications, like moving stuff around and having images change everything. And in order to do that, we need another language, and that language is JavaScript. So to kind of show where everything fits in, so this section is Introduction to JavaScript and Client-Side Scripting. So I'm going to define this client-side and server-side right now. So we're right here. Okay, client-side, server-side. Okay, so I'm going to draw this picture again. That squash. You're going to get really tired of this picture. And then there's the internet, and then there's a server somewhere. So this is called the server, and this is usually called the client. People also call it the browser because you're in a web browser, but usually people say this is the client, this is server. So when people say client and server, client is in terms of the web, client is your computer, and server is there. So there can be many clients for every server, right? The whole idea of a website is that many people's laptops and phones and whatever and iPads and stuff are visiting. Is that an iPad? Yeah. Huh? Yeah. All these are clients and there's one server. The idea is that there's one server, there's a bunch of clients, and the server is giving all of them files and such. So when we say server-side scripting, server-side scripting is everything that happens on the server side right here. So what languages have we seen for server-side scripting so far? There's a lot of... Yeah, so CGI is sort of the protocol we're using, but it's not a specific language, right? So we use Python. What other ones have we seen, or have you seen from the readings? Java, PHP. Good, so basically any language, right? So the server-side scripts can be written in pretty much anything you want. Perl, Ruby, Java, basically anything you want can be a server-side script because the server is just a computer and the server-side script is just run a program on the computer. So the important thing is if someone asks you, what language do you have to use for server-side scripting? The answer is any language you want, as long as your server can run it. As long as the server, whoever you're renting it from, runs that language, you're good. So server, you get basically you get to have any language you want. Because the idea is you just need to be able to process the requests. You need to be able to process the HTTP requests, do something with it, and then give the client back something via HTTP. That's all you need to do as a server. You can do whatever language you want. Now, in the client, things are a little different. So what languages can you run on the client or in the web browser? So HTML, good. So that's the markup language for displaying your page. Yep. So CSS, which is what we've already learned. So we want to have HTML, CSS. Those two run the browser. And then what is the next one? JavaScript. Good. So those are the three. Whoa, we can't spell. Those are the three languages that run the browser. So a lot of people consider HTML and CSS kind of not programming languages. They're more like markup languages or description languages. If you think about it, they're kind of describing what the page looks like, but they don't look like a programming language like here's a variable, here's a for loop, here's a thing. So when people categorize programming languages in the browser, a lot of people just say JavaScript is kind of the only programming language in the browser. Even though these are other languages, right? You have to learn the syntax and everything. But when you're thinking about languages, JavaScript kind of looks like these, right? It looks like they all have if statements and while loops and functions and variables and stuff, whereas HTML and CSS looks kind of different. Yes?
What makes JavaScript so special? Like,
what makes JavaScript so special? Yeah.
Why does it not have like competitors?
Yeah, that's a whole other area. There's a giant Wikipedia page about this. What makes JavaScript so special was that when the first web browser came online, this was at Netscape. Well, this is not the first browser, but so the first web browsers couldn't do JavaScript. The first web browser in 91 or 92 had HTML and CSS, not even CSS. It just had HTML. So the first web browser is display some text on a page in a cat picture. And then someone said, we need a programming language for your browser, right? We need something because I want to be able to write if statements and while loops and stuff. So then this guy who invented JavaScript had to invent a language literally in 10 days. This is a real story. So they're like, the people in Netscape said, we need a programming language now because we need to beat Microsoft, who is trying to release their own web browser. So like, all right, let's do it. All right, so we make it in 10 days, and that was JavaScript. And we've been living with it since. So then it got to be a standard, sort of, and then Microsoft tried to make their own JavaScript that was sort of different, and then they got sued by the government, and then there was a giant thing where Microsoft got sued by the government over JavaScript. And there's a giant story about this you can read on Wikipedia. That's endlessly fascinating. But in the end, basically, as more and more browsers came online, the first web pages in 95 or whatever ran with JavaScript. So then the next version of every browser had to implement JavaScript because otherwise you would break your old pages. And then the next versions had to move JavaScript because more people wrote JavaScript. And then more people wrote JavaScript, and you can't really have another language. Companies like Google try to put other languages in their browser. So for example, Google has this language called Dart that it's putting in Chrome. I think it has it in Chrome. But the thing is, no other company is going to put Dart in their web browser because that's a Google product, right? So then if you make a web page with Dart, it can only run in Chrome. It can't run in Internet Explorer or Safari or anything else. So JavaScript's the only thing that can run in the browser. So the question is, so why JavaScript, right? So it's just because that's the case. And recently, people have started inventing other programming languages to run the web browser to get around this issue, right? Because you're like, what if I hate JavaScript? So there are other languages that run in the web browser, but what they do is, how many of you have taken compilers class? Wow, not many. So what they do is that they compile into JavaScript. So every language that wants to run the browser, there are other languages that people invented. You need to write a compiler that turns them into JavaScript, and then it can run the browser. That's actually not as weird of an idea as you think, but yes?
Python picking up though for client-side scripting? It's like some tools you get into Python.
Yeah, but they're pretty bad. Like they're not production quality. Yeah, I mean there are some, but they're really not up to par. I mean, I don't think people are using it in production on the client. On the server, obviously, Python is used a lot. One of the most, we can talk about this offline, but basically you need to run JavaScript in the browser. If you want to write another language, you need to write a compiler, use a compiler compiling JavaScript. There are several languages that do that, but yeah.
Does JavaScript have any relationship with Java?
That's a great question for that same Wikipedia page. It has absolutely no relationship with Java at all. It has nothing to do with Java. The language looks a little bit like Java, but if you think of it as Java, you're going to be really confused when you try to learn it because you'll have to learn it. and it has nothing to do with Java at all. Then why is it named JavaScript? Because the same geniuses who told that guy to make JavaScript in 10 days, the management at Netscape said he wanted to name it something else, right? Like, I think it's called LiveScript or whatever new programming language it invented. In 1995, Java was a really popular language it was getting really popular for development. And the management at Netscape said, let's name our language JavaScript because it sounds like Java so that people would use it. And that's exactly why it's called JavaScript. And it led to endless confusion. Yes, so that it is a harrowing tale that you can read on Wikipedia. But anyways, upshot here is you basically have to learn JavaScript if you want to do any web development because it's in the browser right here. Whereas on the server, you can use whatever the heck you want. It's a lot more flexible. So what does JavaScript do? So what JavaScript essentially does is in the web browser, I mean. So JavaScript is just a programming language, just like Python or anything else. If you learn it, it feels like a programming language with all the features and quirks that you expect. But the special thing about JavaScript in the web browser is that it can manipulate the DOM. So basically, when you have a DOM right here, that's HTML, right? This is the DOM. This DOM is set. Like I can't do anything with it after I load. The way to do something with the DOM after you load the web page is you write JavaScript. And what JavaScript does is that there are functions that you call that will actually manipulate and change this DOM around. So for example, if I wanted to, for some weird reason, if I wanted to make this this heading start growing bigger and smaller and grow bigger and smaller and flashing in different colors, you imagine writing JavaScript code that has some kind of timer and has some kind of variable that represents the size, and then you loop a bunch of times. Every second what you do is you make the size a little bigger, and then you call some function that changes this my heading font size element, the font size in here, to a little bigger and smaller and bigger and smaller and so forth. So basically anything you want to do with the DOM that you imagine doing, you can do with JavaScript. So that's basically what you use JavaScript for, is to manipulate the DOM. Because without it, you can't manipulate the DOM. Without it, your page is loaded, and then you're just stuck. Like you just have this web page. Like I can click around all I want. Like nothing actually happens. Yes.
Do you have to implement the refreshing into your own scripting, or does the browser automatically listen for changes in the HTML file? That's great.
That's a great question. So you're talking about timers or something,
or something that would automatically
Yeah. So the thing that the browser gives you is that it gives you functionality. The browser gives you functionality like setting timers, for example. So or responding to other events. So we'll actually spend the rest of the class going through that. So the timer example is a simple one, which is the browser lets you do. Let's actually do this. It will look annoying, but so the console here is JavaScript. So when you go to the console in Chrome, what you're typing in the console is JavaScript code. So you might have used languages like Python or Ruby, other languages, where you can just type in code directly to the browser. So you can say x equals 5, and then y equals x plus 10, and what's y, right? So this is JavaScript code. So z equals -1 times y, and z is -15, and z plus x is whatever. So this is JavaScript code right here. That's the language you're writing. And the basic JavaScript looks like pretty much any other language. You have math and you have other things. So in JavaScript, we need to print stuff out, right? So in Python, the function is called print. In JavaScript, the function is called console.log. So hello. And that just prints hello to the console. So this is sort of like so you'll end up debugging by doing a lot of these. So I can say console.log 10 plus 20. And now we'll evaluate 10 plus 20 equals 30 and print out 30. And console.log, hello plus world, and it'll print out hello world and stuff. So that's JavaScript right there. But obviously we want it to do something to the actual DOM, because otherwise it seems kind of useless. You could calculate the time and stuff. So let's do the timer thing. I think it's called this. Maybe I have it wrong. Console.log. Hello. So I'm writing a function. I'm not naming it. I'm just writing a function that prints hello, hello, and I set, this is milliseconds, so 3 milliseconds, or 3 seconds. If I do this right, I wait for 3 seconds, and then the browser will fire and print the hello for me. So there's a thing called set interval, and I think this is the one that does it periodically. I think. So now every 3 seconds, it will call that function I just gave it. And this is how you do the looping and whatever, making this stuff go. And it just says repeatedly say hello. So the thing just keeps on incrementing because it just says I'm printing hello a bunch of times. So you can definitely, let me reload everything. So the console is basically JavaScript. Okay, so you can do all your writing of your code in JavaScript itself. And that's all good because, again, the only thing that runs on your web browser is, wow, it's getting messy, is JavaScript. But a lot of, as working with a lot of languages, you probably want to use some kind of library to kind of make things a little bit easier. So one of the challenges using JavaScript, it's easier now than before, but I think, yeah, well, you mentioned the different browsers thing. So the nice thing about having a server, so I'm gonna erase all this junky stuff. The nice thing about having a server here is all you have to do is, so pick your favorite language, blah, 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 blah. Let's just, whoa. So you have some language on your server that you like. We'll just call it, we'll just say Ruby or something. You have some language. You write your server-side script, right? This implements your login functionality, the database, all the logic, all the looking up stuff, calculating dates and times and stuff. You write and test this code once on your server. Your server is running some operating system. You're running, Linux, version, blah, 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 and you have all this stuff installed. And you have Ruby installed, you have Ruby 1.9 installed, you have these Ruby libraries installed. You're good. You test the heck out of your server, you're good. That means that whoever visits your, whatever clients visit your server, let's draw a bunch of them. There's more. Really belaboring this point here. Whoever visits your server, we're going to do the same thing. We're going to do the same thing, right? And so on. You can imagine. So everybody who visits your server, you're running the exact same code on your server, right? So that means that you write it once and you test it once. You have one set of code to test. Now, what is the issue with all these clients? The issue is that they're running Windows, they're running Linux, they're running Mac, they're running old Windows, they're running really old Windows. They're running some weird operating system you don't know. What web browsers could they be running? Sorry? That's a search engine. That's not the browser itself. Yeah. So what's the web browser software they could be running? Opera. Other ones? Netscape. Lynx. Yeah, this is great. So, yeah, Curl. Yeah, we're getting some really crazy ones. Opera, Netscape, Internet Explorer, Safari, Chrome, Firefox, old Firefox. What version of Explorer? Explorer 3, 4, 5, 6, 7, 8, 9, 10, 11, Chrome, whatever. The idea is that everybody has a different web browser, but there's only one server. So everybody's web browser, we talked about this earlier, implements JavaScript, right? Everybody's web browser implements JavaScript. Well, you hope they would. I mean, the text ones like curl and stuff don't, so we'll kick those out because those can't obviously display pictures and stuff. But everybody's web browser on your computer should run JavaScript, theoretically. So they all should run JavaScript. But the thing is, these web browsers are all made by different companies and different organizations. And there's just not one JavaScript implementation. There's a language called JavaScript that you kind of have to follow, but everybody's implementing their own code base, right? Because Microsoft has their own JavaScript implementation, their own compiler interpreter. Firefox has one, Safari has one, Chrome has one, those people have one, everything. They don't share code sometimes due to proprietary reasons, sometimes due to just practical reasons that they have a code base and they can't, port the code around. So the problem now is when you load JavaScript into someone's browser, there's JavaScript running in their browser, but you don't actually know what browser they have or what weird quirks they have. And every browser implements JavaScript and the DOM, so not just JavaScript, but the DOM itself, a little bit differently, just ever so slightly differently. So if you're just using JavaScript, what you end up having to do is this. So this is a, whoa, what just happened? This is some compatibility page. These are the most common browsers in use now, right? But there's like a ton of other browsers. So there's let me zoom in. There's Internet Explorer. all these major versions, which differ in some weird ways: Firefox, Safari, Opera, and Chrome. Those are the 5 most common ones. They cover most of the browsers. But there's maybe other weird ones too. These are all the different versions. These are the different levels of support they have for the different functions for manipulating the DOM. And other quirks, like, oh, by the way, if you use Internet IE7 and lower, return the, look at that. Like, look what just happened there, right? It's like, yes, this is what you should do, but if you're an IE7 and lower, don't forget that thing. And yeah, it kind of works, it doesn't work, kind of work, kind of work, kind of works. There's a ton of these, right? And it's like, oh, these numbers, the comment node is, whoa, what is that? Lower, the tag name is exclamation, okay? All right, sounds good, sounds good. And there are an infinite number of these things, compatibility issues. This is just a DOM, what is, compatibility. So there are these tables here that, this is what you would get paid 6 figures to do, to look through these tables and figure out what works on different browsers. There are these tables here that implement different things. Also, let's how about that, right? What about web browsers on phones? What about, web browsers on different phone versions? Somebody made Chrome for the iPhone. Someone made Chrome for the Android. Someone made Chrome for everything. Some of these phones might not be as powerful, so the web browser says, we're not going to implement this, or we're going to make this a little slower and stuff. So basically, if you want your website, your JavaScript to work on reasonably well, you have to sort of account for most of the common browsers that people have. Whereas notice on your server side, your job is a lot easier, right? You just write your server, you know what your server is. So you can do this manually, and it's incredibly annoying and painful, or you can use a library to do this that will hide all these details for you. I talked about the philosophy of this class is that we didn't want to use libraries for the purposes of illustrating concepts because libraries hide stuff from us, right? And we want to just try to get as fundamental as possible. But it turns out with JavaScript, it's really hard to do if you don't have an actual library because I don't want to deal with all this stuff. And we want to write code that works. So then there's a question of what library or framework should we use for JavaScript? This is going to turn a very depressing lecture. My friend sent me this comic yesterday, which was amazingly timely. So frameworks are like libraries and stuff. So amazingly timely comic. All right, so we're next one. So which one should we choose to use? This is not even a giant list. So these are the JavaScript frameworks that are popular now. So this Vanilla JS 95, this is like the original JavaScript version, right? This is just use JavaScript. There's a bunch of other ones that look weird and have weird names and stuff, and they come out at different times. They have different market shares and stuff. Again, just to overwhelm you with these web pages, there is, just like the web server frameworks, compared to JavaScript frameworks. Which one do you want to choose? There's a lot. And they all have blah, 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 different features and everything. So this is super confusing. The one that we're going to use is called jQuery, which is right here. Came out about 10 years ago, and it has a dominant market share. It has 65%, whatever number. Basically, over half the websites on the internet, according to some metric, use jQuery. So this is one of the most common ones in use. Yes?
Isn't jQuery going to Manchester?
Sorry?
I thought jQuery was made by an RIT student.
That's right. jQuery is made by an RIT student who dropped out of RIT to make jQuery. And he now works at Khan Academy doing education stuff. Yep, so jQuery was made by an RIT student in 2004-ish. So jQuery is basically the kind of the de facto most popular library for JavaScript for doing stuff. You don't have to use it, obviously. Like there are other ones, there are all these newer ones that people use as well. But jQuery is nice because it's well supported, it's very well documented and such. And where is the jQuery? Yeah, so this is, yep, so 65%, yeah, of the 10 million. So this is the big, yeah, so this is the big quote right here. jQuery is the most popular JavaScript library and used today with 65% of the top 10 million highest traffic sites on the web. And it's free open source and everything. So this is, a good thing to learn to start with. If you're gonna use different frameworks in the future, if you go to your job or internship, they're like, we're using blah, 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 then you gotta learn that blah, blah, blah. You have no choice. But for starting for projects, I highly recommend this because one of the things that jQuery does is smooth out many of the differences in the different web browsers so that you can, in theory, write the same kind of functions and have it work reasonably well confidently well on pretty much all the browsers. Because what the jQuery people did is painstakingly go through those tables and make sure that when you say something, it like translates it in all the different browsers and all the weird quirks and everything. So you don't have to worry about any of that. So definitely use that. Okay, so the rest of the time, so this is kind of, we're set with the conceptual part. The rest of the time, we're gonna write code, and the code we're gonna write is in the JavaScript language, and we're gonna use the jQuery library. So the important thing is that jQuery is not a language. JavaScript is a language. jQuery is a library that you can install on top of JavaScript, so you can download it and install it. Just like how Python's a language, but you can install some third-party library to give you extra functionality you can import. So jQuery is the same idea. Okay, so let's start by our goal this in the next 20 minutes is to make this page do something with JavaScript that's non-trivial. Erase all this. So we're going to get rid of all of these tabs. Lecture 1, maps. Lecture 6. Okay, so we started lecture 6. We're good. All right, so the first thing we want to do is to include, so where you write your JavaScript is, you can, just like the CSS, you can write it all within the same HTML file, which is what we're going to do for the class, so you don't have to have multiple files. But in reality, you should put it in different files, and you can just import them so that you can have everything split into different files. But I'm going to put it all in one file, just so I don't have to switch between files. Okay, so in order for us to actually import the jQuery library, we need some line like, import jQuery or something, right? We need something to tell the web page to load the jQuery library in. One thing you can do that I've done is you can download the jQuery library, which I've downloaded to my computer, and just include it. The other cool thing about JavaScript that's really nice is that because you're on the web most of the time, you're on the web, you can actually just import it just from the website. So you can download jQuery, put it on your computer, and import it. Or what you can do with a lot of these libraries is you could just go to here. You can just actually use the jQuery, where did I put it? I put it down below CSS. Okay, you can just copy and paste this line and put it in your code. So this is, where am I putting it? I'm putting it at the end of the head. There's debate of where you should put it, but just for the purposes, we're going to put it at the end of the head. So after the CSS, I'm just going to throw this line in. I'm just pasting it in. Put HTTP here just to make it a little more explicit. And the idea here is what we've done is we've actually defined a script tag, and we said that the source of this is this URL right here. This, what it will do is when the web page loads, it will start loading the page top to bottom, process, and when it gets to this, it will load, it will just go and fetch that file and just plop it in and load it into the browser. And the cool thing, because we're on the web, we can load it from any website. We don't have to download it to our computer. If we had downloaded to a computer, which I did, you could just go like this, right? Because you can just say, that's the file I want to grab. But you don't have to grab it. You can just grab it directly from the internet. So just to make sure that there's nothing weird going on, I'm just going to copy this, and I can just visit that web page, right? These are all just public web pages. Okay, so what's that? So that's JavaScript code. That's the JavaScript code you should write, by the way. So that's JavaScript code. So what that is this is called a minified version of the code. So what that is conceptually, if you're writing your JavaScript, wow, this actually looks really cool. This is, you can show all your parents and friends. This is what you do when you're coding. Like, this is pretty much what coding is. You just go on like this, and you're like, oh, there's a bug right here, right? There's a bug right there. What people do to distribute JavaScript on the internet often, you don't have to do this because for your projects, is they compactify it or minify it. So you can run it through a processor that basically eliminates all the spaces, first of all, right? That saves some bytes. And it turns all the variable names in A, B, C, D, E. So that it just squashes it as small as possible. Because you want to deliver these files over the internet. So you want to just compact it as much as possible. You don't have to do this. But the libraries are usually distributed in this called .min, like minified format. But it is just code, right? It's just straight up code. I think there's a non-minified version. So that actually looks more sane. That's actually jQuery. Like, that's actually looks like real JavaScript code before it got squashed together. But it's faster to download the minified one. Yeah?
I read that it could be a good idea to use the Google repositories because they're everywhere, and also because maybe it's already cached on your machine.
Yeah, so this is a performance thing. I don't want to go into performance in this class, but one of the advantages, like you mentioned, where is it? Oh, one of the advantages, there's a thing called a CDN, or don't worry, this is totally extra, you don't have to know this, but your point is basically, it actually may be a good idea, instead of downloading the JavaScript file, to actually use the URL. It may be actually faster to use the URL, because a lot of people, so for example, if 100 websites, or 1,000, or every website you visit uses the same URL, then your browser just caches that URL content. So when you go to any website, you have down jQuery already on your computer for free. So it just makes it faster. But don't worry about performance for the class. That's completely extra. Okay, so the idea is we have JavaScript on our computer, and jQuery. So let's actually do something. So we're going to write our JavaScript code down here. You can say script type text JavaScript. And this opens up a JavaScript code. So everything in here is JavaScript. You have JavaScript comments. You can also do comments this way. This is all JavaScript inside now. So just like with CSS, we've inside the HTML file, we'd find a block called type.css, and we wrote CSS code. We define a block in JavaScript, and we write JavaScript code. So the nice thing about HTML files, you can throw everything in one. Sometimes you obviously want to put it in separate ones, because if your JavaScript file is giant, you don't want to throw it all together. Now, so let's just do console.log. Hello world, like that. Okay, that's the first line of JavaScript, and we're going to save it, and then let's run it. To actually see something, we need to go to the console, because console.log prints to the console. So I'm going to reload, and it says hello world. Right. So it says hello world. So the question is, when does this hello world run? When does that code run? So know what you know about how the browser works so far. Yeah?
After you've downloaded the entire page.
After you download the entire page. Okay, that's one answer. What's another answer? We actually don't know. So what's another possibility? So entire page, that's very reasonable. What's the dumber thing the browser can do? Yep. Run against the line. Yeah. So line 1, line 2, line 3, line 4, line 5, blah, 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 line whatever, hello world, and then loads the whole page. So it turns out the web browser is actually pretty dumb. So if instead of saying hello world, I'm going to do alert. Hello world. What alert does is that it pops up you should never do this because it's really annoying. It pops up an annoying box that you have to dismiss. So if you're right and it loads the whole page, we should see the whole page and then alert. If you're right, then we should see alert and then the whole page. So
alert pause the loading.
It will pause the loading, yeah. So that's why alert's really annoying. That's why you have to say, ah. So my page is not, wait, it's already loaded. Here, let me go here. Yeah, all right. So we pause the page. It hasn't loaded yet. I press OK, and then I'm good. So if I actually move this down here, don't actually do this, but if I move this down here like, let's finish loading the truck and then alert, then it'll load the first part and then alert. So let me go here. Right, truck is loaded, it's not done yet, and then it finishes. Right. So the web browser is pretty dumb. It just loads everything as it goes. So now the question is, okay, so that's fine. So our console.log or our annoying alert will run at the very beginning of the execution. So what's one way of trying to get this to run at the very end? Put it at the very end, right? So you can put this at the very end, and it should do what you want. So if you throw it at the very, very, very bottom of your file, you should be reasonably good. That's one way to do it. One of the problems with that would be that, for example, let's say this image takes a long time to load. Then when you fetch this image, the image might not have finished loading first, because it just puts an image tag there and then has to go and do another request for the image. So when you get to the end here, you're not really done with the page. If the page is crazy and complicated, you're still not really done with the page. So this is kind of back to your question of what the browser does for you. So it's still annoying, and you don't know when the JavaScript, well, you do know when the JavaScript runs, but really what you want is your behavior, right? We want to just load me the whole page first so that the whole DOM is constructed. Only after the whole DOM is constructed, not partially constructed, not when the image is halfway loaded. Just give me the JavaScript when the whole page is loaded. So what's one really hacky way you can do that?
Kind of the same way that you include an image.
Okay, so you can include the JavaScript maybe. But then that actually just loads the JavaScript right when you include it, right? So anything is just happens right when you're loading it.
Well, it's like an external resource, maybe.
It is, but then the problem is that the whole page will load, and then that will load, and you don't know when that'll finish because the rest of the page might be slow or fast.
You could do the thing we were doing earlier, just make it like wait a second.
Yes, that's right. That is a great way, maybe. So yeah, just wait a second, you know? How long do you want to wait? 1 second, 5 seconds, or
I
whatever?
think 1 second will give it enough.
Let's do it 1 second. All right, 1 second's good. That's great if your web page loads fast, but if you're on a phone, you're like in the middle of the desert, it's obviously not going to finish loading a second, and you're going to run it halfway. All right, so timeouts are not going to work because you don't know how fast the page loads. All right, so there's really no good way to do it unless the browser tells you when it's finished loading the page. So it turns out the browser is not that dumb. The browser is actually will send a signal to you to the JavaScript code when it finishes loading the page. And the way to catch that signal is in jQuery, there's a thing called a ready handler. So, so this way you can keep all your code in the top. So what happens here in jQuery, this is jQuery like library syntax. There's many ways to write this, but we'll just call it, whoops. This is right. All right, so give a brief JavaScript intro, but basically I'm going to move everything inside this function. Now, how many of you have seen JavaScript before? Okay, most of you have seen JavaScript before. Okay, good. So you'll have to kind of learn more of the details on your own, but basically what this is that this is defining, this thing right here is defining a function with no name, right? This is defining a function. Document.ready, this is the jQuery, a lot of the functions in jQuery start with $. You'll see this a lot. Document.ready is a method or a function call. So this is calling a function. How many parameters does the ready function take? 1. Okay, and what is the type of that parameter? That it's a okay. It's a function, or some people say closure. Yeah, the type of that parameter is a function object. It's an actual function. So in order to do that, we create another function in here, and that actually running that code will create a function object. Sometimes called closure. We can talk about this later. But that function inside means when you call it, it will run that code inside. So the key point, yes.
Are functions like first-class citizens in JavaScript?
Yes.
Or is it like more?
No, they are. They are first-class citizens, so you can create them. So another way to do this, if you want to make it a little bit more clear, a way to do this is the following. Var is to declare a variable. What's your favorite variable name? Foo. This is the exact same thing. So we define a function, which is an object itself. We assign it to the variable foo. Now we're going to pass the variable foo into document ready. Right. The key thing. This is the exact same as the code before. The key thing here is when does this JavaScript execute? This is in the head, by the way. When does this execute? When the page finishes loading or not? It executes in the beginning, right? Because the browser is dumb. It executes. When this line executes, are we going to print console.log? No, we're not going to print console.log because we're just defining a function. We're not actually going inside the function yet. As far as we know, we don't know what's inside. We just said some code is inside. The key here is this code runs in the beginning, and it creates a function object, puts it in foo, and then it will run this function, right? It calls this document ready function. It'll pass foo in here. What this does in jQuery, with the jQuery library, is that jQuery now says that my web browser, when you're ready, call foo. When you finish loading the entire page, after you finish loading the entire page, all the images, all the good stuff, then call foo, like that. Does that make sense? So the document ready, by passing in a function, the key thing is you're not calling the function right now. You're passing in a function object. And after you make this call, then the web browser promises you that whenever the page finishes loading, 1 second, 5 seconds, 30 seconds, 60 seconds later, it will call this function for you. So in this way, we can actually be guaranteed that whatever we run, it will run at the end. So let's do the annoying alert example. So if we do this, the annoying alert should happen even though this code is at the very top of our page, right? This code is at the very top. If we do this, just unlike the other example before, the alert should run after the whole page loads. Right, so it's subtly, no. So we're gonna go here. and load the whole page, and then the alert goes. Right? That's very different than before, where we just stuck the alert outside. If we stuck the alert outside, it'll run as soon as it hits it, and then it's over. Okay, so I'll just throw this all into the instead of using foo, just to make it look a little bit tighter. It's basically the same thing. So so a lot of times when you see jQuery code, you see a document.ready. This means that everything you write here is runs when the page finishes loading. So now what we do is we just want to write code in here. We don't want to write code outside. And the reason we don't want to write code outside is you don't know when the page is finished loading. It's just a lot harder that way. Okay, so what do we do with this code? Let's just make 3 buttons here. Okay, so this is HTML. We're just going to keep this super, super basic. So we're going to have a button. This is just an HTML element. ID equals cat button. Cat. Yeah, we call this cat. Yeah. And then we're going to copy and paste. Everybody's favorite activity. Don't forget to change all these things, the IDs, because you can't have 2 different IDs. So this is dog. This is bear. This is all HTML, no JavaScript, no fanciness. So in HTML, you can label every DOM element with a special ID, just as a string. All right, and it's a good idea this because we're going to use these to identify the buttons. Because it's like, which button are we talking about? We're talking about the cat button. These are just names. The other thing I want to do is I want to name this thing. We're going to call this, did I call this in my demo? I'm going to call this main image. OK, so now I have a bunch of stuff. I'm going to save it and reload. Good, make sure it still stays sane. 5 minutes left. Go, go, go. So now I have 4 things here. I have cat button, dog button, bear button, and then I have the truck image. So what I want to do with JavaScript is, so I can show you button right here. All right, these are buttons. What happens when I click these buttons? Nothing happens because I didn't say any behavior, right? Buttons are just HTML elements. Nothing happens. What I want to do is I want to, when I click one of the buttons, I want to replace the image of the truck with that image, right? Click the cat button, it should be a cat. Click the dog button, it should be a dog, and so forth. So you have to use JavaScript because you're in the browser. The page is already loaded. You can't do this if you don't have JavaScript. So what I want to do is if I click cat, I want to put the cat picture right there. And to do that, I want to just replace the DOM element. So conceptually what I want to do is right here, there is a DOM element here. This element has a source attribute. And this source attribute is the truck, right? What I want to do is when you click the cat button, I want to change that from truck to cat. It turns out you can actually manipulate the DOM. So it was misleading to say that you can only do it with JavaScript. You can actually manipulate DOM directly in your browser. So you can do this. There we go. I just changed the DOM. And then I can change it. You can manually change it in your browser. But obviously, you have to write a program to do this, right? You can't just manually go on people's browsers and change stuff. It'd be really shady. All right? You can manually do that. You should do this to your friends' things, too, when they're not looking. Because that's how you make like fake news headlines, or you go to the news webpage and you put their name in. You're like, this person got arrested for this terrible crime. It's like their picture on the CNN homepage. You can do that because you just go to the homepage and just change the picture of their picture. You have to be on their computer, though. OK, so I changed the DOM. I can also delete stuff from the DOM. Like if I just feel like deleting this my heading, I don't like this, I just press delete. I just delete this. So it turns out with Chrome, you can actually change the DOM. Now, am I changing the original HTML file by doing this? No, right? I'm not editing the HTML. I'm changing the DOM. So what happens when I reload the page? It goes back. That's the key part, right? I'm not changing the file. I reload the page, I'm back to my original boring trick puck photo. So changing the DOM is only in memory, right? Like this is all just manipulating the browser's memory. So what I want to do is I want to write JavaScript that does this for me. I don't want to do it by hand. So let me reload. So to do that, first I need to do something when the user clicks the button. So I need to write a function that executes when the button is clicked. So jQuery allows us to do this in a really elegant way using what's called a click handler. So in jQuery, the first thing we got to do is we have to select the cat button. We need to say what button are we talking about? So to do that, the first line of code we write is We're just going to do the $sign in a string cat button. So this is JavaScript as a language, but this is jQuery library syntax. So the $sign is the jQuery library, and you're going to pass it a string. That string, if you have an ID, it's called a pound sign. So you can read all about this in documentation. Pound means ID. So this says, give me the element in the DOM that has an ID of cat button. So if you read that, that should give you a reference to this button right here, this cat button. So if you want to verify this for yourself, don't take my word for it. Go to your console. This is why it's important to have your console open. I'm going to copy this in my console, and I'm just going to run this, paste cat button. That gives you, right there, you see I highlighted and there's a cat button highlighted? So that actually gives you the actual object of the cat button. So that's a nice thing about having the console open, that you can actually debug this by yourself. So for example, if you misspell it, which is really common, so let's say I just say cat button without the pound, it gives you nothing. So it gives you an empty list right here. It says, I can't find anything. If I say pound cat button, it's that one. If I say dog button, it's that one. Bear button, it's that one. All right. So the first step in the jQuery is to find the button you want to do something with. So the cat button is the right one. The second step is to do something with it. So the thing we do is we need to do something when we click the button. So we're going to set what's called a click handler. So we're going to do .click. This is, again, a function, and it takes a function in as an argument. So if you're not familiar with JavaScript, you have to really study up on this idea of creating a function here and passing it in as an argument or a parameter to another function. This is pretty central to everything. And what this says now is when you click this button, I'll have all this code online later. Let's be annoying. Let's do alert. So when I load this page, I run this code, and I set up so that when you click that button, it's going to put up the alert meow for me. If I don't click the button, there's no alert, right? The alert will never run until I click the button. And then let's see what happens. Save. Say 2. And there we go, right? And then there we go again. Dog, bear, don't do anything. I can just copy and paste the code of dog, bear as well. So obviously we don't want to just do alert. We want to do something a little better. We want to set the main image now. So how to get the main image? Main image. Again, let's make sure we have it right. So I'm going to copy into the console. This is how you should be debugging, because you can. Main image is this truck, right? I spelled it right, just confirm. Now what I want to do is I want to set the source of the main image. So jQuery, again, gives you functions to do so. The function is called attr attribute. So this is a call. This is the jQuery function call. This says set the attribute. Attr means attribute. Set this source attribute instead of to truck to cat. So it says, give me the source attribute and throw cat in there in the source attribute. It says, give me the main image, give me the attribute source, and set it to cat. And if I execute this right, then it should change to the cat. All right. And now if you actually look at the elements here, it's actually a cat now, right? Everything, this is the DOM. I've just modified the DOM with JavaScript and jQuery. So I can change this to, yes, question?
Is that why hashtags are a thing?
Is that why hashtags are a thing? I think hashtags are a thing because of Twitter, right? Maybe.
Like, is that why?
Oh, is that why people use hashtags on Twitter?
Yes.
It's a great question.
That's what originated the code.
Maybe. That's a really interesting question. I never thought about that. Somebody at Twitter, they're writing so much code with hashtags, they're like, hashtag cat. That could be possible. Yeah, because you need some letter or thing in the front, right? You could be an exclamation mark or something. That could well be true. I have no clue. But anyways, we know this works, so let's copy this code back in. And then we will let you go in 2 seconds once we confirm this. So this sets the cat picture. And we're going to save, so we're going to set the cat. And let's run it. And lo and behold, I'm going to click here. And thing changes to the cat. So imagine the dog and the bear, the small applause. Imagine the dog and bear do the same thing. So all this code will be online. And wow, this thing's messy. But remember Piazza, remember Looker, Project Partners, and I'll see you all next week.